Hello, so today we're going to be starting trigonometry, and this is a very important part of mathematics. And let's start. So, what is trigonometry? This is a branch of geometric mathematics that studies about the angle properties of a triangle. So, let me kindly change the color of this. So, it deals with the angle properties of a triangle. So, the first thing we should even know from trigonometry, I think, is the term SOHCAHTOA. And SOHCAHTOA is the abbreviation that we usually use to remember the relationships between sine, cos, and tan with the sides of a triangle. So we are considering a triangle ABC, where this is the, and considering angle theta, where this is the adjacent of this angle. This is the opposite of this angle because it is opposite this angle. This line adjacent is just adjacent to this, and this is a right angle triangle. Then this is the hypotenuse, the slanting side of the triangle. Now the cosine. So you look at this formula, SOHCAHTOA. So cosine, we are going to be writing it as cos. And what is cos theta? It's going to be adjacent out of hypotenuse. And in this case, the adjacent is BC. So this is BC out of the hypotenuse, which is AC. Then now we go to sine. So we look at sine theta will be opposite out of hypotenuse, and what's the opposite? AB. What's the hypotenuse? AC. Okay, and the tangent, tan theta. When you look at from TOA, tan will be opposite out of adjacent. What's the opposite? Opposite is AB. Then what's the adjacent? BC. Now before we go further, we can derive an alternative formula for tan, because we are saying tan theta is equals AB out of BC. Now we want to get a relationship between tan with cos and sine. Now here we're going to borrow a concept from the chain rule. So here we have AB out of, so I'm not sure what I'm doing, out of BC. So let's say if here is 1, of course eventually when we multiply this it will be AB out of BC. But now since we are saying we want to relate tan with sine and cos, you look at when sine is AB out of AC. So meaning I can put here AC and also put here AC. Why am I putting here AC and AC? You realize that I've literally not done anything, because this and this can cancel out to give us AB out of BC. But now we're doing this generator relationship. So you realize what is AB out of AC? AB out of AC is sine theta. Sine theta times what is AC out of BC? And now what cos is BC out of AC? So this is like the inverse, 1 out of cos theta. So now we are getting a third relationship being tan is equals to sine out of cos theta. So now this is an important relation that you actually have to remember going forward. Then now we have, let's start with the secant of angle theta. Secant of angle theta can be written as sec theta. It will always be 1 out of cos theta. This is also a very fundamental thing to remember. Then the cotangent of angle theta. The cotangent of angle theta will be 1 out of tan theta. It will be 1 out of tan theta. But remember, tan is, so this is the same as 1 out of sine theta cos theta. Meaning cot can also be written as cos theta out of sine theta. So now all these formulas have to be, so this can be remembered from SOHCAHTOA for sine, cos, and tan. Then this has to be remembered. You don't have to remember how it comes about, as long as you remember tan is equals to sine out of cos, cot is 1 out of tan, so it's literally the reciprocal of tan. So cot can also be cos out of sine. Okay, so let's look at a few more relationships, then we can a few other identities, then now we can start. Okay, now here we want to look at other identities arising from what we saw. So we saw sec theta is equals to 1 out of cos theta. So sec theta is equals to 1 out of cos theta. So sec theta can also be, so we can cross multiply, so we can have sec theta times cos theta is 1. This is another relationship. We can also now divide through by sec such that we get cos theta is equals to 1 out of sec theta. So each of these is an important, like we're deriving identities from just these few identities we have. And sorry, we didn't talk about cosec. Cosec is another important identity. Cosec is 1 out of sine theta. So you see, sec is 1 out of cos, secant full is secant, cosecant full is cosecant. So cosec is 1 out of sine. So you have to find out, always remembering what cosec and sec are. So even here, this can be written as cosec theta, sine theta is 1. Sine theta, you can divide through by cosec. This is 1 out of cosec theta. So these are very important identities to remember. Then we also have to always remember that tan theta is equals to sine theta out of cos theta. And we also have to remember that cot theta is equals to cos out of sine theta, but also cot theta is equals to 1 out of tan theta. So you always have to keep these identities at the back of your mind as you're going to study this topic of trigonometry. If this is your first time relating with them, I would encourage you probably write them down very many times such that you start introducing the concept to your head. Now we're going to look at another very important thing in trigonometry, the trigonometric ratio of 60 and 30. Now you're going to realize these trigonometric ratios can be gotten from a calculator, but as we go ahead, we're going to find numbers that ask you, without using a calculator or tables, find this. Maybe find tan 60 plus. They know that the ratios 60, 30, and 45, these trigonometric ratios can actually be found without using a calculator. We're going to see how. Now we're going to start with 60 and then 30. Now you should note that when we have, let me change the color of this. So you should note that we have this is be given an equilateral triangle. An equilateral triangle is a triangle where all sides are equal. Let me draw here a small one. All sides are equal. So this, and this is equal. So for this one, we can assume the sides to be 2, 2, and 2. So 2, 2, and 2. And another thing about an equilateral triangle is that all sides are 60. Remember that all the sides of a triangle, all the angles of a triangle when added should be equal to 180. So 60 plus 60 plus 60, 180. But you're saying this side is 2, this side is 2. Now we have to generate a right angle triangle from this. So we divide this into 2. Now this side, let's even label the triangle A, B, and C. So we have a triangle ABC. Now we've dropped a perpendicular. Perpendicular means like we've divided it into 2. Here at an angle of 90. So we'll divide this angle exactly to 30 degrees. And then here, this was 2 also, because this side is 2, this side is 2, this side is 2. Now we have just assumed this size. So this is 2. Even if someone used 4, 4, 4, eventually they will come to the same thing as we're going to see towards the end. Now here we're going to have, this is going to be 1. This is 1 since this side was 2. Now we're going to extract this triangle. So we're going to call this point X. We're going to extract this triangle. This is X, this is B, this is C. So this is 30 degrees, and this is 60 degrees. This is 90 degrees. This is 2. This is 1. Now I want to find the size of, because we don't know the size of the height. So we're going to call this A, B, and C. From the Pythagoras theorem, A squared plus B squared is equals to C squared. So what is A? A is 1 squared. So A is 1, so 1 squared. B is what we don't know, B squared is equal to C squared. What is C? C is 2. So yeah, this is equals to 2 squared. So 1 plus B is equals to 4. So this is B squared. So we have b squared is going to be 4 minus 1. So b squared will be 3. So b will eventually be square root of 3. So here this is square root of 3. Now we want to find the angles of 60. So we can first write so car Thor. So what do I want us to note? We have 60 here, so we can now start sine 60. What is sine 60? Sine 60 is equals to opposite out of hypotenuse from here. So this is 60. So what's the opposite of this angle? It is root 3. This is equals to root 3. What of the hypotenuse? Hypotenuse is 2. So that's the sine of 60. Then now we go to cos 60. So cos 60 is going to be adjacent from here, adjacent out of hypotenuse. So here what do I have? Adjacent is, the adjacent of this angle 60 is 1 out of the hypotenuse, which is 2. So cos 60 is a half. Then tan, the tan of 60 going to be opposite out of the adjacent. So this is going to be equal to opposite out of adjacent. What's the opposite of this? Root 3 out of, what's the adjacent? 1. So you realize we found the trigonometric ratios of sine of 60, sine 60, cos 60, tan 60 without using a calculator. Now you can prove this with your calculator. Just make sure the calculator is in degrees. You write sine 60, it will give you 0.8660, but when you also say root 3 divided by 2, it will give you the same answer, meaning you've gotten the correct ratio. Then if you say cos 60 in your calculator, it gives you 0.5. If you say tan 60, it gives you 1.732, but if you say root of 3, it still gives you the same answer. What does that mean? We found the right ratios. But we found these ratios, and you can see some of them are in form of sets. We found these ratios without using a calculator. So you can find a question asking you without using a calculator, maybe solve this, but there will be angles in maybe 60. Now you're going to see how to get 30. So that is why this is very important. Now we're going to get the ratios of 30. So how do we get the ratios of 30? We're going to use still the same triangle, but this time I want to focus on 30. So let me draw the triangle here, but this time I want to put, okay, but even if we bring it the way it is, maybe let me just change the color to make it easier. Let me see, which color should I use? Okay, let me use light blue, it's visible. So I'm going to redraw the same triangle. So this is our triangle, and this is 30. This is C, this is X, this is B. This is the angle, so I don't want to write 60 since it may confuse. This is root 3, this is 2. So now I'm going to say what is, so the formula stays the same, so I'm going to say sine 30. Sine 30 will be opposite out of hypotenuse. Then what's the opposite of 30? 1. What's its hypotenuse? Hypotenuse is 2. Oh, sorry. Hypotenuse is 2. Then I go to cos. The cos of 30 will be adjacent out of hypotenuse. What is the adjacent of 30? It's root of 3. What's its hypotenuse? 2. Then I go to tan of 30. From here it's opposite out of adjacent. And what's the opposite of that? It's 1. What's the adjacent? It's root of 3. So we have this, and you can confirm with your calculator what's the sine of 30, give you 0.5. What's the cos? So we've found all the trigonometric ratios of sine 30, cos, tan, even the same with 60 without using a calculator. Now see, this is going to be a very important concept in solving specific numbers. So when we reach that point, I'll just be referring us to this video, and I just show now. I'll just start from putting these angles. So now we're going to see how we can get the trigonometric ratios of 45. Then we can now move on. Okay, now let's look at the trigonometric ratios of 45 degrees. Now here we are going to use an isosceles triangle. That's a triangle where two sides are equal. So here we have this side and this side. So we're going to call this triangle A, B, C. So in an isosceles triangle, like we have two sides equal. So we can say maybe this is 90. And we're going to see why, because if these two sides are equal, this is 45 and this is 45. So 45 plus 45 is 90, plus 90, that's 180. Okay, so now we are going to assume we're going to call this side 1 because they are supposed to be equal. Now this is A, this is B. So we want to find the hypotenuse. So it's A squared plus B squared is equals to C squared. But what is A? 1 squared. What is B? Another 1 squared. This is equals to C squared. So 1 plus 1 is equals to C squared. 2 is equals to C squared. And C is root of 2. So we have here our hypotenuse as root of 2. So then we put here SOHCAHTOA. This is SOHCAHTOA. So sine of 45 will be opposite out of hypotenuse. And this is 45, so the opposite is going to be 1 out of the hypotenuse, which is root of 2. Then we go to cos 45. From chi, it will be adjacent out of hypotenuse. And what is our adjacent? 1. What is our hypotenuse? Root of 2. Then now we go to tan 45. So opposite out of adjacent. This is going to be, what is our opposite here? 1. What is our adjacent? 1. So tan 45 is 1. So what do we note? Sine 45 and cos 45 are actually equal. And as I told you that always you can prove, you can try and prove your answer and see if it's correct. Now the next thing we're going to look at is trigonometric graphs. Okay, now we're going to look at trigonometric graphs, and we're going to start with the trigonometric graphs of cos theta. So starting with the trigonometric graphs of cos theta, make sure your angle is in, your calculator is in degrees, and we're going to start each of these. So we start with cos of negative 450, and this is negative 1. So because of time, I'm just going to input them into the calculator as I be putting here. So this is negative 1, this is 0, this is 1, but you can actually pause the video and confirm for yourself. And you're going to see there's a reason why we have to look at these. 0, this is negative 1. Okay, so this is what we have. Now we're going to plot. We're going to plot these points. So I'm going to start with 0, and here on the x-axis, on the y-axis, what we have is, because here this is the angle theta, this is the cos of that angle theta. So on this we have cos theta. This is the y-axis. The x-axis is theta, the degrees. So that is what is on x. So here, when you look at the cos of theta, the first thing I want us to note before even going ahead is that because here we picked all the multiples of 90, so 0 plus 90, 90, you get those are multiples of 90, and we could have kept on going, but we just stopped at 540. But what we can notice that the cos of theta is between 1 and negative 1. The minimum is negative 1, the maximum is 1, because you see, so the values we have here. Okay, so let's start plotting. 0 is 1, so this is here. Then 90 is 0. So I'm going to pause this and plot very fast. Negative 90 is 0. I'm going to pause this and I plot. Then okay, so let's continue. So we have so I've not plotted this. 1/8 is also negative 1. Okay, so I think I've plotted all points. And also negative 450 is negative 1. So very fast plotting this. So the plot may not be perfect, but I just want us to bring out the concept. So this comes like this, sorry about that, something like this. Just want to show us the concept, something like that, like that, that. Okay, this is it. Now, from this graph, as wicked as it is, because when you look at it, okay, in actual sense, it's something like this, something like this. It's the graph of cos. It's like that, continuous. Now, the first thing you should note is the cos of 0 is 1, and the cos of 90 is 0. And also the thing that we talked about here, that you look at the graph is lying between 1, this is 1, this is -1, this is 1 and -1. So you look at the graph is lying, so meaning the maximum value of any cos will always be 1. The minimum will always be -1. And what else? So we can also note what is cos 180. Cos 180 from here is -1. Then what's cos of -180? Cos of -180 is also -1. Let's also try cos of 270 is 0. That is the cos of -270. It is also 0 from here. Then I can also try the cos of 540 is -1, but also the cos of -540 is -1. So what does that mean? That if I have the cos of any, maybe negative theta, it's equal to the cos of, to the value of the cos theta. Like the negative doesn't change anything. And why is this? Because when you look at the graph of cos, the graph of cos is symmetrical. Like the graph of cos, it exhibits symmetry about the y-axis. So we don't call it the y-axis, the cos theta axis. And now to see what I mean, when you look at the graph for sine, you compare and see. So this is very important. And this, because in the future when we meet something like cos of negative theta, we shall actually just ignore the negative, because we've seen that the cos of negative theta is equal to the cos of theta. So that's the trigonometric graph for sine theta. Now we're going to the trigonometric graph of sine theta or at cos theta. So now this, because we've understood the concept, I'm going to pause and do this graph and even fill in these values very fast. Just make sure your calculator is in radians. I'm going to fill this and do the graph, then I pause, I resume when I've redone and I just explain, then we move on. Okay, so I've tried to draw a beta graph. This is a beta graph that I've drawn for sine theta. Now, okay, now let's look at what important things should we note. The same thing we saw last time, that any value, the sine theta is lying between -1 and 1. That means the maximum value of any sine is going to be 1. The minimum value is going to be -1. This is very important. This relationship is very important, as we are going to see for future numbers. The maximum is 1, the minimum is -1. What else should we note? Another important thing to note is that when you look at, because of space, I want to surround this into this. Now let me show us something else. When you look at the sine of 90 is 1, but the sine of 0 is 0. Okay, now let's look at another relationship. The sine of 0 is 0. The sine 180 is 0. The sine of 360, 0. All these can be seen here. 360 is 0. Then the sine of 720, you can get this from the calculator, it's also 0. Then the sine of -180 is 0, as we see from here. Then the sine of -360 is 0. Now what does this mean? You realize all multiples of 180 degrees have their sine as 0. So this is a very important fact. It actually helps you remember the sign of those values. Now what other relationship? What is sine of 90? From here, sine of 90 is 1. How about the sine of negative 90? Sine of negative 90 is negative 1. And similarly, when you look at the sine of 270, you look at here, you look at the sine of 270, it's negative 1. But when you look at the sine of negative 270, what is it? It's 1. So what does this mean? That the sine of negative theta is going to be negative. It's going to be negative times the value of sine theta. Like here, the sine of negative 90 is going to be negative times negative 1, which is 1. Why? Because the graph of sine theta is not symmetrical. Like when you look at this line, the y-axis, or sine theta, this line, when you look at it dividing, it doesn't divide the graph of sine theta into two, because you already see this is going up, this is going up, so already it can't be symmetrical. But now compared to this, when you look at the graph of cos, you see this is cos, but you see it's already going down, this is also going down. So there's a symmetry that this line divides this into two equal halves. So that's why here the cos of negative theta is equals to cos theta. The negative doesn't even change, but here sine of negative theta is going to be negative sine theta. So these are very important graphs. We're going to look at the graph of tan, but these are the most important. For tan, we're going to just see something very small. Okay, now here we have the trigonometric graph of tan. So we're going to use our calculator to start from sine negative 5 forward. From tan negative 5 to here, you get 0 from your calculator. And then tan of negative 450, tan negative 450, the calculator says math error. And that math error actually means that the value is like infinity. Similarly, when you do this will be 0, this will be infinity, this will be 0, this will be this. In the tan of 0, you keep trying on your calculator, you will see what I'm saying. This is 0, then this 0, this is 0. So now we can plot. So you see, when we are to plot the values of when you plot the values of tan on a graph, you realize that tan is not all the multiples of 90. Their tan is giving us math error. It's giving us something, it's undefined actually. That's the right word to use, it's undefined. So meaning tan, if we were to do the graph of tan, we're going to do here at every, okay, so at all the points which are undefined, we're going to draw lines. So here we have at 90, it's undefined. At here at 90, it's undefined. At 270, it's undefined. So we'll draw our dots. Then at 450, it's also undefined. So we'll do this. Then we come here at negative 90, it's undefined. At negative 270, it's undefined. At negative 450, it's undefined. Then now we plot the points we have. We have 0 here, we have 0 here, we have 0 here, we have 0, we also have 0 here, we have 0, the point here we have 0, is the point here we also have 0. So now how do we plot this? So we're going to line. So yeah, now we've looked at this is a trigonometric graph of tan. So now this is a trigonometric graph of tan. We can see it as asymptote because the tans of these values are undefined from our calculator. So I hope this makes sense, and there is no important relationship we should know about the tan, the trigonometric graph of tan. I just wanted us to know that this is how it looks. But this is an asymptote. We'll look at what asymptotes mean more in curve sketching. But for now, mostly focus on the trigonometric graph of sine and cos. Okay, thank you.